It starts with a blur, a smudge on a film reel sent across 4.5 billion kilometers of vacuum. Voyager 2, alone and drifting, had passed Neptune in the final leg of its grand tour, snapping images of the planet's frigid, distant breath. Each photo was a gift, a whisper from the edge of sunlight. Among the frames, one stood out, not because it revealed something clear, but because something moved too fast to be clear at all. In a stretch of Neptune's southern hemisphere, a streak cut sideways across the cloud bands. Not curved, not chaotic, sharp, linear, unnatural. A thin path where the haze of methane clouds has been peeled back, just for an instant. It doesn't swirl like Jupiter's storms. It doesn't spiral like Saturn's poles. It slices, and worse, it travels faster than Neptune's own rotation. At the Jet Propulsion Laboratory, the raw telemetry is reprocessed. Thermal overlays, radiative filters, motion interpolation. The object, if it even is an object, was clocked moving at nearly 2,100 kilometers per hour. That's twice the speed of Earth's most powerful hurricanes. It is supersonic, not by a whisper, but by the width of planetary scales. And yet, nothing breaks. No shockwave, no turbulence, just silence moving quickly. They expect to find a data glitch, a compression smear, a lens anomaly, but the numbers hold. The blur, whatever it is, isn't an error. It's real. The phenomenon is dubbed DS 1989, dark spot, discovered in the 1989 flyby. But it doesn't behave like a spot. It has no core, no spin, no storm wall architecture. Instead, when atmospheric flow models are adjusted, something strange happens. The movement resolves into a path, a corridor, not shaped by chaos, shaped by intention. Neptune is a world of paradoxes, furthest from the sun, and yet home to the most violent winds in the solar system. A planet bathed in frozen hydrogen and liquid methane, wrapped in darkness, yet pulsing with energy it doesn't seem to own. The dark spot should have unraveled, dissipated like all storms eventually do. But it doesn't. It stretches, refocuses, moves faster than the layers above it, and then faster still. It ignores drag. It defies prediction. And yet, it always follows the same latitudinal band, as if anchored to something beneath the clouds. Something buried. Comparing adjacent frames, scientists map the streak's progression. It doesn't rotate in place like Jupiter's red spot. It translates, a storm that moves sideways, carving the same atmospheric rail over and over again. From this, a terrifyingly elegant image emerges. A loop, not of wind, but of patterned emptiness. Like a groove in a vinyl record, turning with invisible sound. Years later, the Voyager footage is reanalyzed using AI-trained visual reconstruction. The streak's edges aren't random. They pulse, very slightly, with a timing interval that matches Neptune's magnetic field rotation, not its atmospheric one. This shouldn't happen. Atmospheric storms don't care about internal magnetism. They are slaves to thermal gradients, to convective plumes. But DS 1989 aligns with something else, as if Neptune's field is not just influencing its weather, it is riding it. Meteorologists try to model the streak as a storm. They fail. Fluid dynamics breaks down under its velocity. Vortex shedding doesn't explain its shape. Turbulence, the universal chaos of weather, is absent. Instead, the simulation converges on a weird solution. A corridor of lower density gas. One so sharply bordered that particles at the edge accelerate into it like they're being pulled. Not a jet stream. A siphon. But to where? There is no drain. No destination. Just motion, cutting across Neptune's sky with surgical precision. One scientist likens it to a blade of vacuum, as if a giant invisible knife passed through the atmosphere and the air followed in its wake. Not because of pressure, because it had no other choice. The deeper question surfaces. Why is this happening only on Neptune? No other planet exhibits wind speeds like this. Not even gas giants far closer to the Sun. Jupiter's Great Red Spot may be larger, older, angrier, but it spins. DS 1989 does something stranger. It doesn't rage. It commutes. In one speculative memo, a fluid mechanic writes, "We're not watching a storm. We're watching a signal made of wind." The idea seems absurd, but when the DS 1989 corridor is plotted over time, it seems to reappear in cycles. Even after Voyager 2 had long since gone quiet, ground-based observatories recorded dim notches in Neptune's albedo, marks that traced similar paths. No core, no spiral, just re-emergence. And now the question isn't whether it's a weather event, but whether it's a system, or worse, a behavior. The story closes for now with an unfinished shape, a speed that can't be explained, a path that cannot be predicted, but always reappears, whispering across the edge of visibility, a corridor in the sky, one that doesn't end, only loops. Again, and again, and again. Storms are supposed to end. They churn, they spiral, they decay. Entropy always wins. But this one didn't. Long after Voyager 2 vanished into deep space, its legacy clung to Neptune like a whisper trapped in cold hydrogen. The dark spot, once thought to be a fleeting streak, refused to fade from science. New generations of telescopes peered into the blue ice giant's haze, expecting silence. Instead, they found a recurrence. Every few Neptune years, roughly 165 Earth years per cycle, a similar pattern emerged. Same latitude, same shape, same sharp-sided streak carving across the upper atmosphere. Slightly dimmer in reflectivity, but unmistakably there. It wasn't a storm. It was a routine. Archived data from Chilean observatories and infrared scans from Mauna Kea were reprocessed, filtered, and layered. The result was unsettling. The corridor returned not with chaos, but with precision. It skipped no step. It drifted no degree. Its path bent slightly to match Neptune's magnetospheric wobble, suggesting it wasn't merely atmospheric at all. Something deeper was calling it into place. Researchers fed the parameters into an atmospheric simulation engine. Standard models failed. The corridor destabilized after 2 rotations. Weather systems are chaotic, after all. But one in turn, working off pattern matching techniques from oceanic vortex studies, changed a boundary condition. Instead of treating the storm as a spiral, they modeled it as a pipe, a long, cylindrical channel of aligned pressures, density gradients, and harmonic resonance zones. And the model held. Not for hours, not for days, but indefinitely. The storm didn't swirl. It conducted. Within the corridor, turbulence was lower than expected. Temperature shifts moved in bands, not bursts. Gas particles aligned into streamlines, like iron filings beneath a hidden magnetic hand. It wasn't weather. It was flow. Not random. Not messy. Deliberate. More scans were ordered. A spectral sweep confirmed that the winds inside the corridor weren't dragging atmosphere behind them. They were pulling from the edges, like a throat taking in breath. Slowly, steadily, with purpose. The term intake valve was used only once, in an internal memo, but it stuck, because that's what the corridor resembled. Not a storm front, not a cyclone, a mechanical aperture. Something that opened, served its function, then faded, only to open again when the time came. But if Neptune has a valve, then what is it pulling in? One fringe theory emerged, that Neptune isn't just radiating excess heat, it's harvesting. The storm, they speculated, could be a planetary-scale pressure equalizer, not to vent, but to absorb. It would explain why Neptune emits 2.6 times more heat than it receives from the Sun. A paradox that's long troubled planetary scientists. Maybe Neptune's heat isn't internal. Maybe it's recycled, drawn in through cycles of atmospheric realignment. A planetary lung, breathing in energy from its own environment, or from beyond. Another model revealed something stranger. As the corridor stabilizes, its internal speed plateaus. Not like a storm gaining strength, like a system settling into resonance. And that resonance, when converted into frequency, matches a low-level magnetic pulse observed at the edges of Neptune's magnetosphere. A signal, recurring, weak but consistent, like a hum vibrating the length of the corridor, from pole to equator and back again. The storm didn't spin, it sang. Ground observatories picked up something new. When Neptune enters specific alignments with Uranus and Saturn, gravitational lensing compresses the solar wind across its orbit. Each time, the dark spot returned, as if triggered, as if the corridor were a response, not to Neptune's own weather, but to conditions beyond it. One astrophysicist wrote in her notebook, "It's not a feature, it's a reflex." To prove it, a thermal pressure model was run using simulated solar flux inputs from 500 years of positional ephemeris. The corridor's appearance mapped tightly to external stimulation windows. The result was clear. The corridor does not emerge randomly. It emerges when called, and always in the same place. Same latitude, same symmetry, same silent intake of air so cold, it would freeze oxygen solid. But it never ices. It never clouds. It just opens, then fades, then returns again. One final simulation, experimental, unconfirmed, attempted to simulate the corridor in reverse. Instead of modeling what entered the path, it simulated what might exit, if the channel flowed outward instead of inward. The result was eerie. Particles didn't exit into open atmosphere. They bent, curved into strange cycloids, paths not explainable by fluid drag or magnetic deflection. It was as if the outflow couldn't escape, as if the corridor had one direction only, a flow that's not reversible, like a valve or a trapdoor. Now the storm is due again. New telescopes, James Webb, the Subaru Array, are aligned to observe. They wait, not for chaos, but for rhythm, a beat in Neptune's lungs, a sigh from the edge of silence, a pattern returning, not because of what Neptune is, but because of what Neptune does. And whatever that is, it is not finished. It was supposed to be a routine drop, a small probe, barely the size of a dishwasher, engineered for one purpose: to enter Neptune's atmosphere and record the wind corridor from inside. The storm had returned, exact in placement, familiar in pattern. A corridor cutting across the planet's southern latitudes with impossible speed. This time, humanity would meet it head-on. The probe launched from an orbital carrier drone, detached cleanly, and began descent with full telemetry. 43 seconds later, it vanished. No explosion, no signal spike, no final scream across the void. Just silence, like a thread cut in the middle of a sentence. Initially, Mission Control blamed pressure shock. Neptune's atmosphere is unforgiving. Composed of hydrogen, helium, and methane, it thickens quickly with depth. But the probe was designed to withstand much worse. Reinforced thermal shielding, adaptive orientation stabilizers, redundant transmitters, everything had been tested. But then they reviewed the internal logs. Up to the final moment of contact, the probe didn't burn. It didn't break. It spun. At exactly 39.4 seconds after corridor entry, its internal gyroscope recorded a sudden shift. Spin rate increased exponentially, not from turbulence, but from torque. A rotational force with no physical contact. No gust, no eddy. It was like space itself began to twist. The stabilizers tried to compensate. Failed. The rotation overtook their ability to anchor the probe. Inside 3 seconds, its axial alignment disintegrated. The onboard clock blurred. Its timing function corrupted as angular momentum overtook even its CPU registers. Then, frame by frame, the final image arrived. It showed nothing. Not debris, not clouds, not motion, just smooth blue. A monochrome field stretching in all directions. No shadows, no edges, no motion blur. It was as if the camera had stopped looking at weather and had started seeing uniformity. The atmospheric structure, turbulent by nature, had become homogeneous. No convection, no differential pressure, no trace of the corridor's violence. Just stillness, inside a speed no object should survive. Scientists compared it to being trapped inside a vacuum chamber that moves. A place where drag exists, but only in one direction. The corridor wasn't storming. It was smoothing. To explain the physics, a radical model was proposed. They called it directional coherence flow. A system not built on pressure gradients, but reality alignment. In this model, the corridor's extreme speeds weren't created by turbulence at all. Instead, turbulence was being subtracted. All chaotic energy was being compressed, aligned, and reorganized, until the flow reached a state of directional purity, like turning white noise into a sine wave, or boiling water until every molecule moves in sync. This wasn't weather. It was processing, a fluid space, refining itself. And the moment the probe entered, it was caught in that refinement, forced to obey a logic not written by aerodynamics, but by pattern enforcement. The spin wasn't failure. It was submission. The question arose: how does such a space exist? What engine could smooth gas on a planetary scale? One theory pointed again to magnetism. Neptune's magnetic field is chaotic, tilted nearly 47 degrees from its rotation axis and offset from its center. But inside that chaos, the corridor always aligned perfectly with magnetic null zones, regions of temporary silence where field lines cancel. In these zones, atomic behavior subtly changes. Charged particles move more freely. Phase transitions occur at lower energy thresholds. In short, the rules soften. And in that softness, the corridor lives. What if the corridor isn't just aligned with Neptune's magnetosphere? What if it's generated by it? Not a storm reacting to weather, but a field-generated tunnel, where atmospheric particles are gradually pulled into resonance, not by force, but by invitation. A tunnel that demands conformity, smoothing all variation into movement. Not chaotic flow, but something colder, stricter. Function. A darker question followed. What else could exist in a place like that? If the corridor removes disorder, could it host structure? Not physical, but patterned, repeated, maintained. Something too delicate for turbulence. Something that waits for the corridor to return. Not to form it, but to enter it. Engineers reviewed the probe's self-stabilization data. They noticed something unnerving. The rotation vector matched a Fibonacci spiral, naturally occurring in biological systems, hurricanes, and galaxies. It wasn't random drift. It was ordered spin, almost like the probe was being adjusted, fitted to a geometry. By what? No one could say. But the implication was chilling. Whatever exists inside the corridor, it does not tolerate asymmetry. Another simulation was run. This time, they modeled the entire corridor as a harmonic shell, vibrating in sync with Neptune's internal acoustic pulses. The output showed the corridor sustaining a self-correcting frequency. Even when disrupted in the simulation, it would rebuild its shape within seconds, as if it wanted to be whole. as if the planet itself had learned to sing one note, again and again, until space bent to hear it. The probe, in the end, wasn't destroyed. It was assimilated, not into a substance, into a process, an atmospheric alignment system, older than memory, faster than reason, and so precise. It erases whatever doesn't match, including a probe, including randomness, including meaning, and still the corridor returns. Again and again, a place not of rage, but of perfection, a wind that doesn't howl, only flows, and within it, a memory too smooth to hold, a speed too pure to trace, a silence that takes. It began with a blur, then a corridor, then a disappearance, but now, after decades of modeling, simulation, and silence, a theory settles into place. Neptune is not howling. It is breathing. The wind, once thought chaotic, reveals a rhythm too precise to be accidental. Each reappearance of the corridor matches not only Neptune's magnetic harmonics, but the cycles of solar activity. It is as if the planet is responding, not instinctively, not blindly, but deliberately, as though it knows when to inhale. Simulations are restructured, not as weather models, but as planetary-scale harmonic resonance networks. What emerges is something new. Across Neptune's equator, density waves travel in repeating arcs, each synchronized with fluctuations in solar flux. Not daily, not seasonal, but pulsed, long, slow undulations that ripple through the atmosphere like a sleeping breath. These aren't random gusts. They follow patterns. Intervals of 1.7 Neptune days, matched precisely to a deep internal acoustic mode. One that aligns unnervingly with the orbit of Triton, its largest moon. As if the moon tugs on Neptune's breath. As if it reminds the planet when to inhale. The corridors, those mysterious supersonic streaks, are not mere storms. They are ventricles, openings in the atmospheric body, pulsing in time with deep, internal waves. One researcher compares it to spherical breathing in insects. Open, close, pause, repeat. Another calls it a planetary exhale. Not to release heat, but to balance pressure across magnetic domains. But the most daring hypothesis is this. The corridor is not for Neptune's sake. It's a listening post, a receptor. In 2029, a new wave of solar observation satellites picks up something peculiar. Pressure ripples in Neptune's atmosphere mirror not only solar radiation pulses, but solar magnetic reversals with timing so consistent, it stuns researchers. The sun flips its magnetic field approximately every 11 Earth years. Each time, Neptune's corridor opens within 14 days. That is not coincidence. That is awareness. If the theory holds, Neptune is not only reacting to its own field, it is reacting to the sun's. It is tuned, like a crystal receiving a signal. Not in audio, not in light, in geometry, the shape of pressure, the weight of magnetism, the echo of heat, all received, all filtered, then translated into wind. One scientist describes it like this. We are watching the respiratory system of a body we cannot see. Neptune is not a planet. It is a drum, and someone, or something, is tapping on its skin. The final discovery is the quietest. Using long baseline interferometry, a pressure wave is detected moving through Neptune's deep atmosphere. It is not strong. It is not fast, but it is stable. Stable beyond expectation, beyond chaos. It circulates in a spiral that does not decay, a pattern that persists across decades of data. No other gas giant shows anything like it. Not Jupiter, not Saturn, not Uranus, only Neptune. And its spiral is not random. It turns inward, back at mission control. The last of the corridor simulations are run. The intake model now shows a full loop, a breathing cycle that pulls particles inward, circulates them through harmonic zones, and releases them gently at a polar vortex. The cycle is too slow for weather, too consistent for coincidence, and too perfect to be ignored. One final question remains. Why? Why would a planet so far away, so cold, so silent breathe? What could it need? What is it listening for? Some think it's energy regulation. Some say it's internal stabilization. Others believe it is an accident of physics, nothing more. But a few, quietly off-record, suggest something else. That the universe does not build storms like this by mistake. That a corridor that erases turbulence is a corridor made for precision. That a rhythm this consistent expects to be heard. Perhaps Neptune is not speaking. Perhaps it is waiting for a reply. Not from Earth, not from the Sun, but from something older, something further. And in that listening, in that coordination, in that silence, it becomes clear. The fastest winds in the solar system aren't chaos. They're attention. And Neptune? Neptune is the only planet in our system whose silence has a pulse.